Okay, now this time for real. So, let's go with 3. We're going to talk about what happens in a material. So, the conductivity of a metal, and this is still just a metal, because if we're looking at something like Ohm's law, it only works for metals. It doesn't work for semiconductors, and it doesn't work for insulators, and so on. So we care about what happens with the conductivity of a metal. Is like the porosity of the rock. So what do I mean it's like the porosity of a rock? Well, what is the porosity of the rock? That's all the little holes that are in the rock that will allow your fluid to flow through the rock, right? So that porosity actually has to do with how fast you can push water through it. And that's maybe not so important for most things that you do, but it's extremely important if you're worried about something like, oh, I don't know, drilling an oil well or something like that, and the oil is flowing through it. Or the water. I mean, you've got 2 choices. You have oil or water underground. So the porosity of the porosity of the rock is like the conductivity of the metal. So that determines the resistance to flow. Okay, so like I said previously, this is our model of a material. I should make it in a better lattice than this, but basically you have a lattice of copper, let's say. Should have done it in orange for copper. And then you have an electron coming through, and that electron will come through and it'll bounce off of stuff. And even though it has all of these empty space, it's mostly empty space in there because, you know, it's charged and some of these atoms are charged. They'll reflect it even though the physical size of the nucleus is so small, right? They'll still reflect the electron. So the electron makes this funny path. And how much of that reflection happens determines how much of your current gets through. Okay? So sometimes we call that the conductivity, but sometimes we call it the resistivity, which is just the opposite. Now, physicists prefer the conductivity, engineers prefer the resistivity, and I think probably that's what shows up in most, I don't know, MCAT things and stuff like that. The resistivity is just the inverse of the conductivity. That is, rho is equal to 1 over G. So this is the resistivity, resist, and this is the conductivity, conduct. Right? And this is a material's property. Okay, this is something that's different for every material. I just said so, right? Resistivity, conductivity differs by material, depends on the size of the nuclei, how many free electrons you have, a whole bunch of different numbers that we won't worry too much about here. But this is a property of a material. And then how you design your wire, for example, will determine how much resistance there is in that wire to the flow of electrons to the current. All right? So the resistance of a wire, remember we just said resistance was important for Ohm's law. Is proportional to its length. It's harder to push something for farther, right? A longer tube takes more pressure to move the water through. And inversely proportional to its area. A wider pipe can push more water through it, right? So if you have a smaller pipe, it takes more potential to push the water through it, more pressure to push the same amount of water through it because you have to go faster, right? So that gives us the resistance equation. R is equal to rho times the length over the area, the cross-sectional area of the wire. And that should be over here. So this is the cross-sectional area. It's sort of the circular cross-section of the wire. It's not the surface area or anything like that. It's the area that the current goes through, right? That we talked about earlier. So this is how we'll get the resistance in a wire. It's a little bit different for different sort of structures, but for a metal, this will always work. All right? For other structures, you don't even have Ohm's law, so you have to do a lot more interesting stuff, which is beyond the scope of this class, quite unfortunately, because it's really fun. So we'll go on and we'll go on later in the next lecture. We'll talk about all of the different circuit elements. We'll talk about batteries, we'll talk about capacitors, we'll talk about resistors, and how to combine them. Then after that, we'll talk about networks. If we have a whole bunch of these things all in a row, or all in a complex network, how do we analyze those networks? And finally, we'll look at RC circuits. That will be the last thing in Module 2, which is about circuits, about currents. And that will be talking about how you charge up a capacitor, how long does it take to do that, what happens in that process for charging and discharging capacitors, and things like that, which people consider very important. It'll have a strong life lessons in RC circuits. All right?